Welcome to section 9.5. We're going to be solving radical equations. Remember, whenever we see the instructions solve or we see an equal sign, our final answer is going to look like x equals some number. Okay, so this is a little bit different than what we've been doing in chapter 9. We've been simplifying before, but now we're looking for actual solutions that make an equation true. So some examples of a radical equations are something like this. So notice we have our equal sign, and we do have some sort of radical. In this case, we have two cubed roots. Okay, so let's look at a simple example. Let's say we wanted to solve this. So the square root of x equals 4. So perhaps you guys can already tell that the square root of 16 is 4. But another way we can go about solving that is we can square both sides, because we know that squaring gets rid of square roots. And now the square root of x squared is just x, and 4 squared is 16. So we would say the answer is 16. And again, we know this is true because square root of x, square root of 16 is 4. So that's kind of like our little check. When we do this step, when we square both sides, like we did here, that's an operation we haven't done before. We've added a number to both sides, we've multiplied the same number to both sides, but we've never squared a number or squared both sides of an equation. And it comes with a warning. So let's consider this really basic example, x equals 6. And we're going to do just that. We're going to come in and we're going to square both sides, and we're going to solve. Okay, so now x squared equals 36. And if we wanted to solve for x, we could take the square root of both sides, yes? And our square root property says that we have to add a plus or minus. And so now our solution is x equals plus or minus negative 6. Okay, and half of this is true. The answer is 6, because remember, x equals 6. But when we squared it, we got an extra solution, negative 6. So, moral of the story, sometimes, it doesn't happen all the time, but sometimes when we square both sides, we get extra solutions, or remember we called those extraneous solutions. And they do not satisfy the original equation. So, just like rational equations, we always had to make sure our solution did not make our denominator 0. For radical equations, we always have to check our solutions. Always. Okay, so let's see how this is going to work. Let's look at an example. And we have 3 root x minus 1 equals 5. Okay, so we have a square root. We definitely see that. If we were to square both sides as is, 3 root x minus 1, we would end up with a middle term that still had a square root. So let's make sure that the square root is all by itself so we don't get that middle term. Okay, and we can take this a step further. We can divide by 3, both sides by 3. And we get the square root of x is equal to 2. And now we know that squaring both sides will get rid of that square root. And so we're going to end up with x equals 4. And now that we have x equals 4, we got to go back and we have to check. We have to check to make sure x equals 4 satisfies our equation. So we want to know, does 3 times the square root of 4 now minus 1 truly equal 5? All right, well, what's the square root of 4? It's 2. 3 times 2 is 6. And 6 minus 1 is 5. All right, so that does satisfy the equation. So x equals 4 is our solution. Okay, let's look at a more complicated radical equation, and let's do it step by step. So here's our equation we're going to solve. So remember, our final answer will look like t equals something. Our very first step is to isolate the square root term. So in this case, we're going to be subtracting a 2 from both sides. So we're going to be looking at t plus 10, square root of t plus 10 equals t minus 2. All right, so now that radical sign is isolated. Step 2, once we isolate it, we're going to square both sides of our equation. On the left, radical and squares just cancel out, so we have t plus 10. But t minus 2 all squared, we're going to have to FOIL that out. And we get something like this after we FOIL. Okay, at this point, if there's another square root term, we would repeat. We would isolate the square root term and then square both sides again. But we're all done. There's no more radical terms. So now we're going to go on to step 4. We're going to solve the new equation. And remember, if it's a linear equation, we isolate our variable. If it's quadratic, we make one side 0. And this one is quadratic. So let's make one side 0. So let's subtract the t from both sides. Let's subtract 10 from both sides. And now that equals 0. After we make it 0, we can use our quadratic formula, or we can factor. This one is factorable, except not like that. So two numbers that multiply to -6 and add up to -5 are -6 and 1. And then we use our zero factor property, our zero factor property. And these are our two candidates, -1 and 6. And they're proposed solutions. So now we have to go back to our original equation and make sure they each work. All right, so let's see what happens. Let's do t equals 6 first. So we'll plug it in to square root of t plus 10 plus 2, and we want to know, does that equal t, which is 6? All right, so does the square root of 16 plus 2 equal 6? And it does, because 4 plus 2 equals 6. So we know t equals 6 is a solution. Let's check out -1. So does t plus 10 plus 2 equal t? So does 9 plus 2 equal -1? That already sounds kind of funny to me. And 3 plus 2 actually does not equal -1. So t equals -1 is an extraneous solution, so we're going to throw it away. So our only solution is t equals 6. And that's our final answer. All right. This next example, notice we have two radicals in this solution. So let's see how we're going to do this. So we're going to go through our first step. Let's isolate one radical. I'll subtract square root of x plus 5 from both sides. And then once we isolate one radical, we come through and we square both sides. Now remember, this binomial on the right will have a middle term. On the left, however, radicals and square roots cancel each other out. And then over here, let's see, if it's a minus b squared, it's going to be a squared minus 2 times a times b plus b squared. Okay, so you guys can verify it with the formula, or you guys can FOIL it out. Let's see, we can simplify this. We can do the 16 and the 5. And this is what we have. And notice at this step, we still have a radical. So we're going to have to repeat the process. We're going to have to isolate our new radical right here, and then square both sides again. All right, so let's see. What are we going to do? Let's subtract an x. And we'll subtract a 21. And let's see what we get. X's will cancel. That's negative 24 equals negative 8, square root of x plus 5. And then let's divide out by negative 8. And so we're dealing with positive 3 is equal to the square root of x plus 5. Whew. All right. And now we isolated that radical, so let's square both sides. And I'm going to flip sides too. I like to get the x on the left. So now x plus 5 is equal to 9. Subtract that 5. X equals 4. X equals 4. Okay. Do we have space to check? Well, it doesn't matter. We have to check. So here's a little space bubble for us. So is the square root of x minus 3 plus the square root of x plus 5 equal to 4. So let's see, this is going to be square root of 1 plus square root of 9. That's 1 plus 3. And indeed, that equals 4. All right, so it satisfies, x equals 4 satisfies our original equation. So that is our solution. All right, let's go ahead and look at our next few problems. You guys can push pause, and let's try to solve these radical equations. Okay, welcome back. So in this first one, you guys subtracted 8 from both sides. And then right off the bat, maybe this gave you kind of a warning. We have that the square root equals a negative number. Square roots can never equal a negative number. So at this step, we actually could have said no solution, because square roots are always positive. Alternatively, we could have squared both sides. Perhaps you did square both sides. And you got this tentative answer that x equals, what is that, 21? And then when you went to go check it, perhaps then you saw that it could not equal 2. All right, so either you caught it at the first step or you caught it when you checked your solution. Okay, number 2. This one's already isolated, so we can just come in and square both sides. Remember, w minus 5 has that middle term. Okay, and then it's a quadratic, so let's make one side 0. You guys subtracted 3w. You guys subtracted 3. And then you factored. Two numbers that multiply to 22 and add up to negative 13 are negative 2 and negative 11. So your potential answers, when you set them equal to 0, are 11 and 2. All right, and then when we check, we have to make sure they work. We can check 11 first. So if we plug in w equals 11, 3 times 11 is 33, plus 3 is 36. So does that equal 11 minus 5? And the answer is yes. All right, and then let's check in 2. When we plug in w equals 2, 3 times 2 is 6, plus 3 is 9. And does that equal 2 minus 5? It does not. 3 does not equal negative 3. So our solution is just w equals 11. Okay. Number 3, we have 2 square roots. So let's isolate one of our square roots. And I'm going to isolate square root of 6 plus x first. So I'm going to subtract root x from both sides. And then I'm going to square both sides. Okay. And then, let's see. Well, we still have that square root of x. Let's isolate it. Here, and I'll write this in 2 if you want me to include that step, and I should. There you go. So subtract the x, subtract the 9. So we have negative 6 root x equals negative 3. And then you divide both sides by negative 6. And you get 3 over 6, or 1/2. All right, so again, we've isolated that radical sign. Our next step is to square it, because squaring gets rid of the radical. And we have x equals 1/4 as our solution. Okay, so let's check x equals 1/4. So we'll plug in 1/4, so 6 plus 1/4 plus the square root of 1 over 4. Okay, so right here we need a common denominator. So multiply top and bottom by 4. 6 is the same as 24 over 4. And then you add a 4th. So you guys got 25 over 4. All right, 24 over 4 plus a 4th is 25 over 4. Plus the square root of 1/4. We can take the square root of the top and the bottom. And we get 6 over 2 when we do that addition, and that is 3. And was that what we were trying to get? Yep, our original problem, that whole thing is supposed to equal 3. So x equals 1/4 is our solution. All right, some nice practice on our radical equations. Let's look at this. Next we have the cubed root of t equals negative 2. So when it was the square root, we had to square both sides. What do you think we have to do if we have a cubed root? How could we get rid of that radical sign? We would have to take the third power of both sides. All right, and now index 3 and power 3 cancel each other out. And negative 2 cubed is negative 8. Okay, so whatever the index is, we can raise both sides to that power and it would cancel out. So let's look at another example. All of our steps are the same. In other words, we would isolate our radical first, so we can subtract 5 in this example. And then we would come through and we would take the 4th power, perfect, and we would get 3x minus 1. 3 to the 4th is 81. And now it's a linear equation, so we would isolate x. That means add 1 to both sides. Constants go on one side, variables stay on the other. Whoops, I said add 1. 81 plus 1 is 82. And then you would divide by the coefficient to get 82 over 3. Okay, and now just as before, we would plug it back in to check. So is the 4th root of 3 times 82 over 3 minus 1, is that equal to 3? Well, let's see. The 3's cancel, so we're left with 82 minus 1, which is 81. And what's the 4th root of 81? It's 3. Perfect. And so that, whoops, 82 over 3 is our solution.